Aerogel is the lightest and least dense solid substance in the world. It is so light that although a given volume of aerogel contains nearly as much air by volume, its mass is only slightly higher. That is why it is called frozen air. How did such a light substance come into existence? How is aerogel made? And what is aerogel used for? We are all familiar with jelly. Jelly is essentially a mixture of solids and liquids. In jelly, most of the content is liquid, and that liquid is held together by a three-dimensional solid structure. This solid structure consists of innumerable nano-sized pores, and it is this structure that gives jelly its stability, much like the rigidity provided by a human skeleton. In 1931, Professor Samuel Kistler and his colleagues conducted an experiment. The experiment was about whether one could extract the liquid component from jelly without destroying its solid structure. In other words, whether the liquid could be separated from jelly while keeping the solid network intact. From that experiment, aerogel was invented. Now, you might think that this is a very simple matter. What exactly was the experiment about? If we heat jelly, the liquid component will be driven out while the solid structure remains. However, there is a problem. When you extract the liquid molecules through heating, the solid structure contracts because the removal of liquid causes the structure to break down and shrink. Professor Samuel Kistler solved this problem. He realized that if you replace one type of liquid with another, the solid structure of the jelly will remain intact. He took silica gel as a model for jelly and immersed it in alcohol for a long time so that the liquid contained in the silica gel was replaced by alcohol. Then he placed the silica gel in a high-pressure vessel called an autoclave and filled the vessel with liquid carbon dioxide. After that, he applied high pressure and high temperature until the carbon dioxide reached its supercritical state. In this supercritical state, carbon dioxide behaves as a semi-liquid and semi-gas. Consequently, under these conditions, the liquid trapped within the solid structure of the silica gel can be easily extracted without damaging the structure. In this way, aerogel is produced. Professor Samuel Kistler published this invention in 1931. Even today, aerogel is considered a very important material. Aerogel is essentially a bluish, transparent material. Under ultraviolet light, it appears pink, and under infrared light, it appears completely transparent. Now let's discuss the applications of aerogel. Aerogel works exceptionally well as a thermal insulator. When cold or warm air molecules pass through its nano-sized pores, their energy is significantly reduced. As a result, only a very small number of air molecules can pass through, a phenomenon known as the Carnot-Sen effect. Thus, when you cover an object with aerogel, it loses heat very slowly, meaning cold objects remain cold for a long time and warm objects stay warm for an extended period. For this reason, NASA uses aerogel in various projects. For example, the Sojourner rover, the first robot sent to Mars, was deployed in 1997 in Mongolia. Aerogel helped keep its robotic components cool in extremely cold conditions. The Curiosity rover, another robot sent to Mars, also utilized aerogel. Furthermore, in modern times, aerogel has found widespread use in other sectors in Mongolia as well. Aerogel contains extremely tiny pores that can absorb small particles. That is, it can trap them. Because of this property, aerogel is used in conjunction with stardust collection, as dust particles moving at speeds of up to 6 kilometers per second can be captured. If any other hard material were used instead of aerogel, the dust particles might bounce off and fail to be captured. Aerogel is also used in the construction industry. Some companies have blended silica gel with fiber tissue to create fabrics that feel much lighter than conventional materials. Another notable property of aerogel is that it is waterproof. If you touch the aerogel with your hand, water will not adhere to it. Therefore, aerogel is also used in waterproof paints and in some cases in fabrics. However, aerogel has one drawback. It is very fragile and can break easily. Scientists are working on this issue, and hopefully in the future more durable aerogel will be developed. When that happens, aerogel might be used in high-rise buildings or large structures to provide insulation. For example, If a house can be insulated with 6 meters of fiberglass, using Aerogel might only require 6 inches of material. For the devotees of material science, the fundamental formula E=mc2 explains why it is not applicable in all cases. To understand this further, please watch the video. If you like it, subscribe to the Science Sphere for more scientific insights.